Hey there, drone fans. Rick here again from Drone Valley. In today's clip, I'd like to discuss two more predictions I have for the changes I expect to show up in the brand new Phantom 5 product by DJI. Now, to be fair, I have no idea what they're working on. I have no insight into the roadmap. I don't really know any of their engineers over there. I have no secret relationships on their development team, although I wish I did. But I'm firmly convinced that there's been an army of wizards working on innovations in this space for the last year in some secret undersea laboratory that's going to produce a new quad, and I believe they're going to call it a Phantom 5. And again, all my speculation is based on my engineering background, innovations that have taken place in this quad space in the last year by other companies, and even changes that DJI has made to their own products. So what I try to do with these clips is sit back, again, as an engineer, and think to myself, if I were part of their development team, what would I change? Based on the Phantom 4, the Mavic, and the Spark, what would I change for this next Phantom 5 product? And these predictions are all based on my insight and what I would suggest at those meetings if I were part of that team. So the two I'm going to talk about today have to do with power and propulsion. And both of those are critical to this new Phantom 5 product being better than previous generations. They also directly relate to safety of the quad. And I'm going to spend a lot of time talking about that. But I'm going to break this series, as I said in the beginning, into a bunch of different clips. Today I'm going to spend time on those two topics, power and propulsion. I've got some pretty interesting concepts that I think may show up in this new quad. So stay tuned and I'll get into it. A reliable and substantial power source is one of the first factors that any engineering team has to wrestle with when designing a new quad. Picking the exact right battery for the platform you're developing takes time and a lot of thought, because that battery not only has to support the quad flying for as long as possible, it also has to have enough current in reserve to support all the other onboard electronics that helps to fix the position of that quad in the sky. So things like telemetry, GPS coordination, video streaming, connection topology between the quad and the remote control, all those circuits require additional current that battery is responsible for. Now, it might seem like an easy decision. Let me just pick the biggest battery I can fit in that quad, slap it in there and go off and fly. But you'll find that the more powerful batteries, the one with the highest current rating, typically are a lot heavier. And the heavier battery I put in the quad, the more energy I've got to use getting that quad in the air. So it becomes a sort of a law of diminishing returns after a point. So the trick is finding the right battery that's not too big, not too small, somewhere in the middle. I call it the Goldilocks zone, where it's the exact right battery for that quad. And really what it comes down to is a concept called energy density. Now, what that means is the amount of power a battery can supply or current it can supply versus its weight. And when I compare the DJI batteries, whether it's the Spark, the Mavic, or the Phantom, DJI has some of the highest energy densities of any batteries I've looked at. And a lot of it has to do with the controlling circuitry inside these batteries, because they're really intelligent batteries that are constantly having a conversation with the quad to deliver just the right amount of current that's needed for that quad to stay exactly where it is at that given moment. So they squeeze every last bit of electron out of the charge in their batteries. Most other quads are not that good. But the other challenge is they're all based on lithium polymer technology. They don't actually develop that. That's developed outside of DJI and they use it in their batteries, but they don't have a lot of control over that. And lithium polymer chemistry is a fragile chemistry that's fraught with a lot of issues. So for example, one of the dirty little secrets about LiPo batteries is that you damage them every time you charge them. Not a lot, but a little. But if you make mistakes and you charge them too fast, too hot, or too cold, you could damage them a lot during that charge cycle, and it's not readily apparent. So you can charge it, fly with it, but you've dramatically reduced the amount of life that battery has. The way you damage them is inside the battery when you're charging it. Reversing that chemistry inside the battery can create things called dendrites, which are little fingers that go between the cathode and the anode inside the battery, and they're like miniature short circuits and dead cells that'll no longer take a charge. Over time, you develop a lot of those dendrites. If they get really severe, like if you charge that battery in a very hot environment or a very cold environment, you could have a short circuit between that anode and cathode, and that's when you get spontaneous combustion. Under normal conditions, a battery just decays as more and more of these dendrites develop. Now, the good news is that the LiPo technology behind the batteries is not standing still. So there's a lot of development on the next generation of LiPo batteries. And there's also some development going on at the University of Michigan about reducing dendrites, understanding how those dendrites are created and minimizing the ability of those dendrites to form. So hopefully something good will come out of that. As far as the battery technology goes, One of the developers of the original LiPo cells, I believe his name was John Goodfellow, one of the original brilliant guys, is in his 80s right now, is working on another version of the LiPo cell that doesn't use a liquid substrate. It actually uses a solid glass substrate. So it's radically new technology. The Tesla guys have tested it. It's like a super secret project. And that may be the next generation of LiPo cells. But until that comes about, we're still stuck with this energy density conversation of today. So all this conversation leads me to my conclusion that even though these batteries are brilliant, my prediction for the Phantom 5 is that it will have 2 batteries minimum. And the reason I say that is because having 2 batteries gives me a couple of things right out of the gate. The first thing it gives me is redundancy, because as much as I love these batteries, there's still a single point of failure. So if the controller goes bad, or one of the cells goes bad in flight, or worse, a connection issue takes place, maybe the battery's not fully seated and it pops a little loose, that quad's coming down out of the sky. If I have 2 batteries in there and I lose one of them, that second one should provide enough current for me to land that quad safely. So I think just based on reliability, there'll be 2 cells in that new quad. The second thing it does for me is allow me to put batteries with a very high energy density in there and have 2 of them in there to give me tremendously high current available to that quad over time. So let me just take a minute and I'll talk about the energy densities of the ones that I have in front of me. I know I'm going to probably sound like a total nerd here, but I thought I would take a minute and explain what energy density is and why it's such a great metric to use when comparing 2 batteries. Simply put, energy density is the ratio of a battery's charge capacity versus its weight or its mass. Now, in a perfect world, you'd want to have an incredibly powerful battery that weighed next to nothing, but that's almost impossible to build because to create that battery, you've got to take chemicals, put them inside the case of the battery, and the more chemicals you add, typically the higher the capacity of that battery, which is a good thing, but it also increases the weight, which is the bad thing. So the challenge is finding that perfect middle ground between the right amount of capacity and just enough weight so that the quad can get up in the air. Now, the energy density formula is very straightforward, and you can apply this to any battery you've got, but what this formula will give you is a real number you can use to compare one battery against another. And the formula goes the voltage in volts times the capacity of the battery in ampere hours divided by the weight in kilograms. And that'll give you a number called the energy density that's measured in watt hours per kilogram. So I thought it'd be fun to look at the 3 batteries I talked about before, the Spark, the Mavic, and the Phantom 4 Pro, because if I'm in the design lab at DJI and I'm putting together the new Phantom 5 and I'm in charge of the battery, I'm going to look at what I've already built and see if there's something I can do to use some of that technology in the new quad. So let's look at the Spark first. So the Spark is a 11.4 volt battery, has a capacity of 1.480 ampere hours, and it's got a weight of 0.095 kilograms. So if I do the math on that, I come out with an energy density of 178 watt hours per kilogram. That's a very impressive number compared to a lot of the cells on the market. Next, I'll look at the Mavic. Now again, same voltage, a little bit higher capacity, a lot higher weight, but I come out with a higher energy density number, so 192 watt hours per kilogram. So I'm very impressed by that Mavic battery. Now when I move on to the Phantom 4 Pro, I'm thinking in my simple mind, it's got to have a higher energy density because it's higher voltage, higher capacity. But think about it, it's a heavier battery. So when I do the numbers on that, I come out about the same as the Mavic, 191 watt hours per kilogram. So as impressive as that battery is, because it's got a lot more capacity and a lot higher voltage, it really doesn't give you a lot of extra energy density. So if I'm sitting down to design the battery that goes in the Phantom 5 and I have to choose between these 3 batteries, I'm going to pick the Mavic battery. So let me just do a little mental exercise here. If I take that Mavic battery and I want to reconfigure that to actually work with the new Phantom 5, I'm going to assume for a second that the Phantom 5 is going to use the same voltage as the Phantom 4, which is a 15.2 volt battery. Inside the Mavic, which is only an 11.4 volt battery, that tells me immediately that the Mavic battery has got 3 individual cells, because the cells themselves are about 3.8 volts. So if I break open that Mavic battery, again conceptually, and I take individual cells out of it, I know each one of those cells is 3.8 volts, about 1.2 ampere hours, and it's got a 0.080 kilograms of weight. Now to build the battery for the Phantom 5, I've got to take 4 of those cells because I want to get to a total voltage of 15.2. So building that Franken battery, I'm taking those 4 individual cells, putting them together inside of a case, which will end up with a battery that's got 15.2 volts, 5.13 ampere hours with a weight of 0.320 kilograms. But remember, I want to have 2 batteries in that Phantom 5 because I want the redundancy, I want the ability of those batteries to survive if one of them fails. So essentially what I'm going to do is build 2 batteries with that exact profile And that means overall, the Phantom 5, if I use two of those batteries, or those Franken batteries I just put together, I'm going to end up with a total voltage of 15.2 volts, 10.26 ampere hours, with a weight of 0.640 kilograms, which puts me at about a 244 watt hours per kilogram. So that's way above where I was before. Now what that means is, if that Phantom 5 ends up weighing about the same as that last iteration of the Phantom 4, I'm going to have a whole lot more capacity built into that, which allows me to fly a lot longer. So that would be the battery I'd build if I use the components that are on the market today. I guarantee you that there's newer technology out there, and they've gotten way better with the controller to build a much more efficient battery. So it'll be interesting to see where they end up. But again, my prediction for this is there's going to be a dual battery in that new Phantom 5, and it's going to be constructed roughly about these numbers if I'm going to build this thing from scratch. I hope that last section wasn't too nerdy, but I really like to understand the science behind any new technology so I can explain what's possible with the gear. So to be clear, I fully expect the new DJI Phantom 5 to have a dual battery strategy for a couple of important reasons. The first has to do with reliability. I've talked before about the batteries, and no matter how smart you make these, whatever testing you do against them or quality control you apply to them, there's still a single point of failure because there's only one of them in the quad. And if something goes wrong with the battery, maybe a couple of cells fail, maybe the controller goes offline, or even something as simple as the battery shaking loose inside the quad, you've now eliminated the only power source to keep that quad up in the air, and it's coming down. So by introducing a second battery, I've now got an additional power source that on that rare occurrence of a battery failure, and that's really rare, I got the assurance that I've got enough power to keep that drone aloft and land it safely. So I think that's the first reason they're going to do it. Now, better yet, if they build a new quad with separate power boundaries inside the quad, which means the connections and the wiring inside the quad have separate paths up to the main printed circuit boards, that's another level of redundancy. So we'll see where they go with that. But I think DJI has been vigilant about making their drones safer every time they come out with a new product, with crash avoidance, return to home functionality, all kinds of things that are built in to make these quads incredibly safe. This would take it up a notch by introducing that elimination of the single point of failure of the power source. The second reason I think they're going to do it is that they're dependent on the evolution of LiPo technology. So as much as they'd like to claim that they've done things with LiPo, the development of LiPo is outside of the control of DJI at this point. There are battery companies that are fast and hard at work on developing new technologies for LiPo to increase the energy density. So when they're going to release it, DJI is going to look at the market and decide what LiPo cell they're going to use. To build it into one battery is going to be a big battery, and it's going to take a long time to charge it. By splitting that capacity between two separate cells, it now gives you the ability to pack a lot more energy density into those cells. And I went through the math in the last section. So having the dual battery strategy gives them more power for that quad. And if they're smart and design it to be less weight and maybe even a smaller frame size, they're going to be able to fly longer because of the additional current and all the other things they do to increase the efficiency. So we all know that the metric people look at when they're buying a quad is how long will it stay up. It's one of the key metrics people ask me, how long can you fly that thing? You could see them. They just broke the 30-minute barrier with one of their quads. I'm convinced that if they do this right, they may actually approach 40 or 45 minutes of flight time. Who knows, even further than that. So how cool would that be? I also think, as the last reason, that it would allow me to do a hot swap with the battery, which means if my batteries are getting low, I can bring it down, pull one out, swap it, pull the other one out and swap it without rebooting the quad, which is not a big deal, but it takes a couple of minutes to go through that power on routine. By swapping those batteries hot, like I do today on the Inspire 2, it allows me to keep that quad live right on the ground and swap those batteries out. So those are some strong reasons, I think compelling reasons, as to why DJI is going to go with the dual battery strategy in the Phantom 5. So we'll have to see if that plays out or not, but I'm convinced at this point that you'll see a new design that'll include two batteries about the capacities I talked about in that last section. In this section, I'd like to cover the topic of propulsion, which typically involves several critical engineering and design decisions that can directly impact how well a quad flies. So things like how long it'll fly, how quiet it is when it's up in the air, its efficiency, its safety, all these things come into play with these design decisions. And I fully believe that DJI is going to make several of these changes on the brand new Phantom 5 when it's released to do two things primarily: make it a quieter quad and make it more efficient. And I think that these changes will directly impact how that new quad flies. Now, I'll give you several examples of what I think are going to change, and there's really three areas that I think are going to be impacted: the propellers, the electronic speed controls or ESCs, and the airframe itself. But I believe that DJI is making these changes, again, to chase that efficiency and the quietness, but I also believe they're going to impact the safety with some of these changes, which is a critical thing for DJI. And unlike a lot of other companies that build quads out there, that typically go out and just buy stuff off the shelf, and they'll buy an ESC from this guy and a motor from that guy and propellers from that guy, put them together in an airframe and let the thing fly. DJI has consistently innovated in the space. So a lot of the changes they make to their quads are first to market changes. These aren't things you're going to see on other quads, and I think you'll see some of that new tech coming in the Phantom 5. So let me start with the propellers. Now this is a Mavic Pro Platinum propeller I have in front of me, and I've talked a lot about this. I actually did a clip on this when I announced the Mavic Pro Platinum and the Obsidian version of the Phantom 4 Pro. They've made some changes to this propeller which are fundamentally different than all the other propellers they've released up to this point. If you look at all the propellers from the very early Phantom products all the way up to the Inspire 2 products, the Mavic, the Spark, they've all got fairly similar designs. This is a radically different design for a couple of reasons, and I've talked again about it in another clip, but I'll go through it here briefly. For starters, the prop is wider, which means you've got a larger surface area, which improves the lift. It's also got a more pronounced curve underneath, which allows it to cut more air and actually divide the air quicker and give it additional lift. And you've got this raked wingtip in the end here, which actually pulls back, which again reduces the amount of vortices out at the tip, which makes it quieter and more efficient. So just the changes they made, the 5 or 6 changes they made to this prop, makes the prop much more efficient and a lot quieter when flying. And that's a good thing, because the efficiency allows you to fly the quad longer with the same amount of battery inside of it. So I expect these changes will show up on the Phantom 5. Whether it ends up being a rigid prop or a foldable prop, I'm not sure, but I expect that it'll have a raked wingtip on the end like this. It'll have a wider prop distance here, and it'll also have a bigger curvature on it. One other thing they may consider, and I've seen this on a few quads, and I actually use these blades on my Phantoms, are a tri-prop design. Now what this does is give you, again, additional surface area. These can spin slower. They can also be quieter up in the air, because spinning slower means you're not going to make as much noise up there. And this gives you better efficiency in the quad as well. So you may actually see a single prop like this where it's got 2 blades, or a tri-prop like this. And there's also versions of these that fold like these guys. So this could be one of these tri-props with 3 blades on it that fold. The minute you spin up the motors, you're going to actually have it fold out like that and fly. So I think the first design change will be the propellers. I fully expect they'll have all the design elements we saw on the Mavic Pro Platinum built into the props that come in the new Phantom 5. The next area has to do with the ESCs. The other major change on the Mavic Pro Platinum was the fact that they went from a standard square wave ESC to a new advanced sinusoidal wave ESC. Now I've talked about that in the other clip as well, but fundamentally what that means is the actual electronics that drive the motor and send the pulses to the motor to make the motor spin are either a square wave, like you see a diagram here, or they're sinusoidal. The difference between those two waves are that the square wave is a much more aggressive wave. It's either on or it's off. There's no in between. A sinusoidal wave actually has a gentle curve from being on to being off to being back on again, and that's much more efficient when you drive a motor with that. It also is less jerky, so if you were to slow those motors down and actually see them move with the square wave pattern, you would see a very jerky motion of that motor at very slow speed. With the sinusoidals, it's much smoother because you're turning on one magnet as you're slowly turning off another magnet to draw that propeller through its rotation. So sinusoidals are much more efficient, they're quieter, and I think you're going to see those definitely in the new Phantom 5. What's interesting about DJI in general is that they design these things themselves. They don't just buy an ESC from somebody else and stick it in the quad like I said earlier. These are designed by DJI. Typically the chips are programmed by them, so it's a much more sophisticated design than you'll probably find in other quads out there. So I expect between the new props and the new ESCs, and maybe even a new set of motors, you're going to have a much more efficient quad that's going to be a lot quieter. All right, this last prediction is a little bit radical, but I'm going to take a chance here because I think this may happen. They've got 4 motors on that quad today, so we call it a quad because it's got 4 motors. The challenge with a 4-motor quad is if I lose any of those motors, or I lose any of the ESCs, or something happens in the wiring up to that motor, and that motor fails, I can't fly that quad with 3 motors. So if I have a single point of failure in any one of those 4 motors, and it fails, the quad's coming down out of the sky. So it's safe because that's a really rare thing to have happen. But if it does happen, it can be a catastrophic failure to the quad. The addition of a 5th motor would guarantee that any one of those motors that failed, I could still limp down to the ground and land that quad safely. It wouldn't come out of the sky. So as I know there aren't a lot of pentaquads out there or pentacopters out there where they have 5 motors and 5 blades, but I would not be surprised if the new Phantom 5 showed up with a 5-prop design. And I've got a couple of examples here of artist rendering. There have been a couple of quads built that are kind of hobby quads. I know the Dragonfly project was one that had 5 motors on it, and I've seen other airframes that have had 5 motors. The physics are not as reliable as an even number of motors, because if you have an odd number of motors, obviously you've got counter rotation on the props to keep it up in the air, and what's that 5th motor going to do? You're going to find that it's going to rotate the same as 3 or 2 others. But you've also got all kinds of physical problems with it. So the physics behind the torque in flight is something you have to balance out. But if you have a smart enough controller, you can actually make that 5 motor quad fly pretty efficiently. And it also builds in the safety that if I lose one of those motors, I'm still not going to come crashing down. And that's something that DJI has been pursuing with a vengeance in the last couple of designs, is to make those quads as safe as possible when they're in the air flying. So I know I'm gotten on a limb in this last one, but I fully believe you're going to see the new props, the updated props, the ESCs, and I really think you're going to see a 5-prop quad, or I should say 5-prop copter coming from DJI. It may very well be the first pentacopter released from any major corporation out there that's going to fly for consumers. So we'll see how that turns out. Okay, so that's pretty much it for this clip, and just to review, I covered the power and propulsion. On the power side, I think you're going to see a dual battery strategy in the brand new Phantom 5. There'll be the latest state-of-the-art LiPo cells that are inside that battery pack. There'll be an intelligent controller designed by DJI to protect the battery during flight, during charging, and during discharge. I also fully expect that those batteries will be hot swappable, just like they are in the Inspire 2 now, where you can land them, pull out a battery, put a fresh one in, pull out the other one, put a fresh one in without rebooting the quad. On the propulsion side of the house, I think you're going to see 3 major changes, like I'd mentioned in that section on the topic. You're going to see a new propeller design that's going to be much more efficient and quieter. You're going to see new ESCs that are going to move from a square wave to a sinusoidal wave, and you'll probably see an airframe design change, which will be the biggest surprise, where you'll have 5 props on there instead of 4. Now, I have no information if any of this is going to happen, but I like to look at these engineering problems and figure out how I would design around them if I was actually building that product, and these are the changes I would make if I'm designing that new Phantom 5, which again, I think will be a radical departure from the previous generation of Phantoms. It'll be fun to see how close I come to the actual product release, but let's keep our fingers crossed that some of these make their way into the new Phantom 5. So that's pretty much it for today. I really enjoy you guys watching these clips and seeing the comments below and sort of calling me out on aspects of the technology. If there's anything I've missed or you've got questions about anything I've covered in the clips, drop them below and I'll get back to you as quickly as possible. Thank you so much for subscribing. If you haven't subscribed yet to the channel, hit the subscribe button down there in the corner and join the family, because I have a lot more content coming. I spend a lot of time thinking about these technologies, and I love putting these clips together to try and explain it from my viewpoint. I'm a hobbyist just like you guys are. It's just a lot of fun to fly and a lot of fun to think about this stuff. So thanks again for watching. Until next time, happy flying.